So let's look at the answers for identifying what types of numbers you're working with. The number 6 we did together. -8 was both an integer and a rational number. 2.5 was the same as 2.5 when converted to a decimal, and it ends or terminates, therefore it's a rational number. Remember, any number that has a decimal is either going to be rational or irrational. -1/3 is the same as -0.3 repeating or -3 cups repeating. This is a repeating decimal. It is rational. 5/11, we had to put that on our calculator, divide 5 divided by 11, and we ended up with 0.45 repeating. Since it's a repeating decimal, it is rational. And -4 and 17/23, when I divided 17 by 23, I ended up with this infinite decimal that had no pattern to it. Therefore, this is an irrational number. So the next thing we're going to talk about in more detail is integers, now that we understand what an integer is. Now, as I talk about integers, I will be referring to numbers that are both negative and have fractions, and therefore I'll also be talking about rational numbers, since integers do not have fractions or decimals. So there's a couple of ways to think about integers. Integers, negatives and positives, can refer to direction. So if you look at this basic number line, home is always at 0. That's always where we start counting from. So if I count to 4, I always start at 0 and then count over 4. And then west is our negative direction, east is our positive direction. So if I am at home and I move in the positive direction, then I'm moving east. If I move in the negative direction, I'm moving west. Another way to think about negatives that we tend to think about more often is opposite. Negative actually means opposite. So if I am moving in the opposite direction of the positive direction, then I'm moving in the negative direction. So the opposite of 5 is how this is read, and that means -5. The opposite of -5 means +5. Absolute value is different than opposite. Absolute value means distance. So the notation for absolute values is vertical lines around the number. So this is read the absolute value of 6. The absolute value of 6 means the distance from 0 to 6 on the number line, which is 6. So absolute value of 6 means I'm looking at 0 and I'm looking at 6. And I'm trying to figure out how many places I moved from 0 to get to 6. And that distance is 6. So the absolute value of 6 equals 6, because the distance from 0 to 6 is 6. The absolute value of -6 means the distance from 0 to -6, which is also 6. So distance, then, is always going to be positive. Distance is always positive. That's different than direction. Direction can be negative or positive. So if we look back up at the top here, direction can be positive or negative. But the distance between numbers is always going to be positive. So when we're talking about distance, we're talking about absolute value. And here are some examples. The absolute value of 4 is going to be the distance from 0 to 4. So see if you can figure out what the absolute value of 4 is. If you said 4, you're correct, because that's the distance from 0 to 4. See if you can figure out what the distance is from 0 to -10 on the number line. The distance is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the distance is 10. Distance is always positive, so even though we're moving over to -10, we're only moving 10 spaces, which is positive. Now we're going to look at the distance between 0 and 3, which, of course, is just 3. So the absolute value of 3 is 3. We'll do some practice problems in a minute. So let's start with some practice problems with opposites. Now that we understand what opposite and absolute value are. So the opposite of a positive 6, what do you think that is? If you think negative 6, you're correct. The absolute value of negative 6, the opposite of negative 6. What do you think the opposite of negative 6 is? If you think it's positive 6, you're correct. Next we have the opposite of the sum of 6 plus 5. In this case, we need to add what's in parentheses first using our order of operations. So that gives us the opposite of positive 11. So what do you think the answer would be there? If you think it's negative 11, you are correct. In the next problem, we have the opposite of negative 7 plus 5. Here we're going to find the opposite first, and then we'll add. So the opposite of negative 7, what do you think that is? It is 7 plus 5. And then we can add to get 12. Now I'd like you to pause the video and try this next page. The opposite of negative 17 is 17. The opposite of positive 20 is negative 20. The opposite of 5 plus 4 is the opposite of 9, which is negative 9. 3 plus the opposite of 4, the opposite of 4 is 4, gives you 7. Let's move on to practicing absolute value. So again, absolute value is the distance from 0 to a number on the number line. So what do you think the absolute value of 2 would be? It's 2. That's the distance from 0 to 2 on the number line. What do you think the absolute value is from 0 to negative 2? Again, we're counting over 1, 2. So again, our distance is 2. Distance is always positive, and when we're finding absolute value, we're always finding the distance. Therefore, absolute value is always positive. So let's do some problems together. So what do you think the absolute value of negative 5 would be? It's going to be 5. It's always positive. What do you think the absolute value of positive 5 would be? It's going to be 5 as well. So again, absolute value and opposite are different. What do you think the absolute value of 9 minus 2 would be? Well, first we're going to want to subtract here. In the next problem, I have to actually subtract before I can take the absolute value. So the absolute value of 9 minus 2, well 9 minus 2 is 7, so the absolute value of 7 is 7. So in the next problem, I'm going to need to take the absolute value of each of these first before I add. So what's the absolute value of negative 5? It's 5, right? Now what's the absolute value of 5? It is also 5. Once again, remember, absolute value always gives you a positive number because you're finding distance, and distance is always positive. So 5 plus 5 is 10. In the next problem, we have that opposite of the absolute value of 7 minus 5. So here, I need to work with inside my absolute value bars before I take the opposite. You're always going to treat your absolute value bars like parentheses with your order of operations. So here I'm going to subtract first, so 7 minus 5 is 2. Now I'm going to take the absolute value of 2 and then find the opposite of that. Well, the absolute value of 2 is 2, and the opposite of 2 is negative 2. In the next problem, I'm going to take that absolute value of negative 14, then I will find the opposite of that. Absolute value of negative 14 is positive 14. And then the opposite of positive 14 is negative 14. On the next page, there are some problems for you to try. Remember, once again, absolute value is always positive. So pause this recording and try these problems. For the absolute value of negative 7, you should have 7. The absolute value of 8 is 8. The absolute value of 7 plus 8, you need to take the absolute value first. So show me that step. Then take the absolute value of 15, which is 15. In the next problem, you have to take the absolute value first in each of these. So the absolute value of negative 15 is 15. The absolute value of negative 10 is 10. And you should have 25 as your final answer. The next problem, we have the opposite of the absolute value of 10 minus 4. Well, we need to work inside the absolute value of bars first, like their parentheses. So the opposite of the absolute value of 6, because 10 minus 4 is 6. And then the absolute value of 6 is 6, and the opposite of that is negative 6. In the next problem, we have the opposite of the absolute value of 23. Well, the absolute value of 23 is just 23, and the opposite of that makes it negative 23. Then we have the opposite of the absolute value of negative 27. First, we want to take the absolute value. The absolute value of negative 27 is 27, and the opposite of that makes it negative 27. So we are done with this part of the video.